All right, guys, how we doing today? I just want to walk you through one of the sample problems for using the ideal gas law. I think we did this one in class, but just so you can go back and check this out, we're going to do that again right here. So we've got a balloon with a volume of 2.34 liters. It's at 47.5 degrees Celsius and 98.2 kPa. How many grams of helium are contained in the balloon? So we've been doing some problem solving where we write down what we're given, the unknown, and our solution. So let's go through that process here. Looking in the problem, I see some information right off the bat that is probably going to be useful. That 2.34, that's a volume. So V equals 2.34 liters. We've got a temperature of 47.5 degrees Celsius. You should have some alarms going off right now that we need to convert that into Kelvin right away. And that turns out to be 320.65 Kelvin. Our pressure, P, equals 98.2 kPa. It's asking us how many grams of helium are contained. So we need mass of helium. Probably recognize that in order to get to mass, we're going to need to calculate moles first. So that'll be our first step. Our solution for this one, this is like we have one set of conditions. So our ideal gas law, PV equals nRT, is the equation that we need. We've talked about like the Chaudhua versus Glad methods of doing things. I'm going to show the Glad method first. Since we're solving for n, I'm going to rearrange this equation right from the get-go and solve it for n instead of plugging the numbers in and then doing the algebra and arithmetic. So to rearrange this, I'm going to do PV over RT equals n. When I come over here and plug in my values, P is 98.2 kPa. V is 2.34 liters. R in this case, remember we're going to look at our pressure units, and because we're in kPa here, we're going to need the value that goes along with that. And the value for R is 8.314. And then our units are kPa times liters over moles times Kelvin. And T in this case is 320.65 Kelvin. All right, so now we recognize where each of those pieces are here. The last part will be to calculate that out. And when we do all the work on this, remember we multiply these numbers, divide by the product of these two numbers. So you may want to write down that intermediate step, multiply these together, and then divide them. When I did that, I end up with 0.0862 moles. All right, so the last step we're going to need to do is converting 0.0862 moles into grams, because that's what the last part of our problem is. That's what the question asked us. We have helium, so 0.0862 moles times 4.00 grams per 1 mole. And I actually didn't do this one ahead of time. Sorry, guys. I'm going to wait for me here. 0.0862 times 4.00, 0.345 moles or grams. All right. I hope that helps. Check that out, and we'll see you soon.